So today we will be talking about alkene or olefin metathesis. I am here with Anna-Isabel Gill, and my name is Yuliana Lopez.
So what is olefin metathesis? An olefin metathesis reaction is a chemical reaction in which two carbon-carbon double bonds, or olefins, unite and exchange their side chains with one another, thereby creating new olefinic products. There are three types of olefin metathesis reactions: ring closing, ring opening, and cross metathesis. However, only ring closing and cross metathesis favor the former reaction. This is because one of the products produces ethylene, a gas, and because ethylene is a gas, it will immediately evaporate, and due to Le Champollière's principle, the reverse reaction will be suppressed, and therefore the former reaction will go on and be favored. Reactivity for these mechanisms is due to the metal catalyst, because it is a carbene, and carbenes are highly reactive species due to the presence of both a lone pair of electrons and an occupied orbital. The products obtained from these types of mechanisms are used to make polymers that are used in the production of baseball bats, tank armors, and porcelain for bathrooms. As I previously mentioned, there are three types of olefin mechanisms. Ring opening is the breaking of the double bond within the ring to relieve ring strain. Ring closing is the joining of a double bond within the ring. And cross metathesis is the joining of two alkenes from two different molecules. Some pros and cons of the alkene or olefin metathesis include pros such as the fact that this type of reaction does not create any side products, or more importantly, it does not create any hazardous waste products. Therefore, it is safe for the environment. There's also steric strain, which helps drive the reaction to completion. And some cons is that if other functional groups are present in the reactants, there would be a lack of selectivity for the alkenes.
So here we have the mechanism for the ring closing olefin metathesis. And what we are doing here is we are still stitching together two alkenes within the same molecule. These alkenes in the benzene ring are not reactive in an olefin ring closing metathesis because they do not react in the typical way that the alkenes present at the ends would. The catalyst, which is comprised of a metal double bonded to a carbon, binds the two internal carbon and forms a double bond between them. Once a double bond is formed between the two internal carbons, ethylene gas will be released as a byproduct, and that can be identified by the two CH2 groups at the end of this molecule we see here. An easy way to think about this is by first circling your internal carbons. You then want to count the number of carbons, not including the two external carbons that will be released as ethylene gas. The metathesis catalyst will form a double bond between the first carbon and the last carbon, thus yielding a ring. The total number of carbons within our final ring product will be equivalent to the total carbons present in the starting material. As you can see here, we have 6 present carbons in our final product and 6 present carbons in our beginning product. And as you can see, the 2 external carbons were also released as ethylene gas. Ring closing occurs when 2 double bonds within the same molecule are tethered together within the same molecule. So looking at our ring opening example, with ring opening metathesis, we are opening the ring to relieve strain within the cyclic compound. As you can see, we have circled our internal carbons in blue. The double bond identified here will be breaking as shown by the red squiggly line. Upon breaking, 2 ethyl groups will form on the external carbons and an alkane is formed as a final product. The alkane consists of the same number of carbons present within our starting material and is a result of the cyclic compound's reaction with a metal catalyst. For cross metathesis, we are stitching together 2 alkenes present in 2 different molecules. As you can see here, we have identified our internal carbons once again with a blue circle and have identified the bonds that we will be breaking with a red squiggly line. The CH2 groups at the ends of both molecules will be released as ethylene gas as a result of the reaction with the metal catalyst, and we will also have formed a trans-dibromo compound. As you can see, olefin metathesis is a very important reaction, even though it is simple, which leads to many great products that we use in our day-to-day lives. Keep this in mind when answering what is the main application of this reaction and what are the obtained products and precursors for. Another question we have is for you to predict the starting material which will lead to the following product.